Okay, so now that we've seen how it used to be built and that the modern way of doing stuff is actually the RBD packed object, let's talk about this topic a bit more because it's quite important. As we've already seen, internally, this is actually always packed. So whatever happens in the RBD bullet solver is in a packed form. It doesn't mean though that we have to input anything as packed, but you will see very often we will do this. Currently, if we don't use the fuse, so just our geometry, we've seen that our object will fall apart in its different elements. And of course, we can check this, by the way, with an exploded view. So if you're not sure, you can always double check what happened by using the exploded view to visualize whether an object is staying together or not. And it's kind of surprising that the RBD bullet solver automatically kind of recognizes that. And this is actually part of the packing object. And to explain this a little bit, let's actually pack the geometry ourselves. Now, what we can do for this is, of course, simple pack. And what we see here when we middle click is that it just packs everything we give it into one point, which, by the way, we can use an add to kind of make sure we delete geometry but keep the points. And there's our point, right? There he is. That sometimes helps to understanding what's actually going on. So it's one point, and if you run this now, what you see is that we actually simulate our object as one piece all of a sudden, and we haven't used the fuse anymore. So this is just the test geometry the way it is. Interesting. This shows you that internally something else is going on. It's just not just using a pack. And the node that is actually internally used is called assemble. We will talk about this node a lot because it's very important and can be very confusing because it kind of does multiple things at once. But this is the first time we want to talk about it. And basically what it does, if I run this, it has a couple of other things turned on, which we will see does something quite important. But by itself, it does not actually pack the geometry. Only if I say, use this actually to pack stuff, it is actually now packed. And this is interesting now. All of a sudden, it has 10 packed fragments. And this is what the create name attribute, surprisingly, is actually doing. This says that this node is supposed to analyze whatever I give as an input and find all the pieces this thing is built of, and then actually give it a name attribute we'll talk about much later. This is kind of an internal identifier to clearly define what piece is what. This is a big topic. We will talk about this later. Just keep in mind that if you turn this on, this is what the assemble is doing. And if we use this instead of a pack and we run this, you can see that it now is working as, one piece is simulated at a time. When we go inside of the RBD bullet solver and actually look for this block that I showed you where the packing and analyzing is happening, there is the assemble node. So this node is used internally and we will do this ourselves. What this also shows you is you can do all the stuff that it does internally yourself outside, and very often this is a good idea. So for now, just keep in mind, you can put in packed or non-packed. Internally, it will always be packed. It uses the assemble node for that, and this is a very important node that we now see the first time. For now, just remember that what the assemble node is doing differently to the pack node is that it finds every piece and gives it its own point, so to say. And finally, the last thing I want to show you is when you use a packed input, like now, you will also, out of the simulation, get a packed output. This is important to remember later on when we want to do something with our RBD simulation. At the same time, if we, as an input, do not use a pack geometry, then we also get an unpacked geometry. So kind of the system internally, again, it does pack it, I can guarantee you that, but it kind of recognizes, oh, whoever gave me my input didn't pack it, so I assume he doesn't want to have a packed output, and kind of recognizes that and unpacks it before it gives it to you. So just keep that in mind. It internally kind of remembers what you did with the input. Now, a small addition to this, you might have noticed when I turned on the create packed primitives in the assemble node that our toy turned gray. This is because of a special function in the assemble node called underneath create packed fragments. Now this plays more a role later on when we talk about fracturing. So if we break our toy apart, or maybe a building or something, But for now, keep in mind, this is why you lose your materials. At least you can't see them anymore. If you turn this off, you get your materials back. So if this is important to you, just turn it off. Now, the reason this thing exists is, like I said, the fracturing. I linked the documentation about this topic on the right. So if you care a little bit more what's happening under the hood, it's an optimization of how the different pieces will be saved in memory. Just keep in mind it's a speed optimization, but it will kill your materials in the viewport. That's all I wanted to say about that. It's not a massively important topic, but you should understand that this function exists. Okay, so much about packing. Again, make sure that you remember the assemble node. It's a very important node, and we'll talk about this more. So that much for now. Thank you very much, and see you later. Cheers.